So as you can see, the agenda of this video is to cover the missing data and how will we do the keeping of it, the drop the data and fill the data. So let's discuss that what is missing data first. In real world, we have missing data at various occasions, and handling the missing data effectively makes us more powerful in getting the insights from the data. There might be two types of missing values: NaN. NaN is a not a number, and PD.NAT. It means within the pandas, not a timestamp. So in the newer versions of pandas, not a timestamp is also one of the missing value. So let's begin. So initially we will be getting these imports of pandas and numpy. After that, let's see that how does this missing data pandas operations work. So if I run this np.nan, it means that the not a number value is being defined. pd.na, na is also not applicable. It is one of the missing value. p.nat is again not a timestamp, right? So now if I run this np.nan equal to np.nan, so what will be the output according to you? Should it be true or false? So all of those who think this will be true, you might want to reconsider it, because when we say that it is not a number, we are not sure about the data type. We are not even sure about even if those two things will be matching with each other. I mean, it can be of a different data type altogether, right? So this will be false, because so two not a numbers cannot be equal. We cannot say it for sure if they are equal or not. Now if I say that np.nan is np.nan, it is true, right? Because they are both not numbers, so hence true. When I assign this np.nan to a and I print it again, nan will be given. Now print a is np.nan and a equal to np.nan. So in first case it will be true, in second case it will be false due to the previous reasons that have been discussed. Now let's discuss about the pros and cons of keeping the missing data and also of removing the missing data. Now if I keep the missing data, it does not change or manipulate the original data, right? But many methods do not support NaN values, and often there can be reasonable guesses. Now because you can make a simple guess, then why to even keep the missing data? You can simply do the guess and get your data better. And there might be a case that when you're running, when you're trying to run a function of numpy or maybe some other function, that nan value is not being considered to do the to solve the problem. Now if you drop it, it can be based on some rules that, I mean, you can decide to drop a particular missing data, a nan value within the column or row, but then you might lose some useful information, and it also limits the training of the model. If you work in a machine learning problem, then if you drop a particular data, let's say that uh, a weather column is not having initially some values, let's say in 4 5 rows initially, and you make a decision on that you want to drop the weather column, but later on for other 95 values the weather values started coming in. Then you had to take decision that now what to do, because your model was not trained on weather, but in the test data, after the training, there might be a case that weather data starts coming in and you want to train your model again. So it is not wise to completely drop the column based on some initial number of rows in the data. You can take other decisions also. We have other options. So let's see that how to deal with this kind of data. Let's say now let's consider that my index is India, USA, and Canada. My data is these things, and my column names are independence, population, and GDP. So if I run this data frame, this is how it looks like. Now there is an NaN value for population and GDP of USA, right? uh, Now if I do this drop na function, df dot drop na function, what it will do is, so because there are NaN values in USA, it will drop USA completely. right? Only those rows are kept in which all the values are there. Now again, if I run this and I say that within GDP, India and USA GDP is not defined, and Canada GDP is there. Now if I try to do this, that I want to drop the GDP column, x is equal to 1. Now I am, in this case, I am trying to drop the data and look into the rest of the data. But obviously, if GDP was kept, it would have been better, right? Now let's try filling in some data. Now there are multiple things. The pros is that you will save a lot of data for your model to be trained on later on, but it is hard to do also. uh, with arbitrary values, you cannot just put the arbitrary values and you can have a go. And it will also have this drawback of leading to false conclusion if your values are not correctly filled in. So let's see, the current data frame looks like this. Now if I want to see the value at this data frame, India and GDP. For India, GDP value is NAN, right? Now I want to print it. So NAN is being printed, right? Now if I want to do this df GDP 0, it means within the GDP, uh, 0 row, right? Again, NAN value will be the output, and for 2, 12 will be the output. Now if you do this, you want to replace the GDP, old value comma new value, right? You want to replace the values within the GDP, but this won't work. And let's try some other method, right? So it is not working, NaN is not being replaced by 0. Now let's try to do with some other method. So there is this simple technique that you can simply replace the values by doing this within the GDP. Zero throw, instead of NaN value, give 0, and again for one location you can give 0, and data frame will be printed. Now in this case there will be some warning, but still our work will be done. So this is a warning. Even if so, if we ignore the warning, we can see that the GDP values have been replaced by 0 because we were trying to replace it with 0. Now if you want to remove this warning, you can simply do it with these two lines: import warnings, warnings dot filter warnings ignore. So if you run this again now, your output is coming without any warning. So there is other technique also, interpolated or estimated values. Let's say that we have this column of percent in which the second value is NaN. Now if we consider that these are in a sorted manner, and 75, 25 are the two things at 0 and 2 location, so this one location must be at the mid of it, right? So we can manually also put the value. I have given this 50%, otherwise you can also do it with this 0 location plus 2 location divided by 2, that function. But there is a automatic way of doing the interpolation. We will look into it within this video. At the end of it, we will do everything. Now let's work on a dataset called moviescores.csv, and let's see that how it looks like. I have already imported the moviescores.csv here. So let's see that how it looks like. Now if you look into it, these are the values within the df, and there are only 5 rows where lots of NaN values are there. This one row is having all the values as NaN, and there are other NaNs also, this one. So now if I do this df dot is null, it will give me the boolean values in form of true and false. Wherever the value is null, it will give a true at that place, right? And here also, again, if you do this not null, it will give me true at values which are not null. Simple, right? Now if I want to do this for this pre-movie score is one of the column here, so in which there are two values which are NaN, and let's do some work on that. Now for that particular column, if I do this not null, it is giving me false false at this 1 and 2. It is not null, right? uh, I mean, for not null, the true value is being given wherever the values were there, and if that was null, it has given false at that place. Now if you want to get the only rows in which the values are coming out to be true, so 0, 3 and 4th row will come out here. So these are the three rows which are the output here using this method, using this technique. Now if you do it with null, same thing will be there, that if there is a NaN value, those two rows will be highlighted. So you can do these two techniques depending upon what you want to do. Now if you want to take care of these two things, that let's say that in pre-movie score the value is null, but in the first name it is not null, right? So I mean that we want to get a row where this value is null. Out of these two, this is null, and first name is not null. So first name is huge here, huge Jackman. We want to get this row out of this. So this is how we can do it. Where pre movie score is null, but first name is not null. So we can do this multiple conditions also. Now if I want to keep my data, it is simple. I mean, do not do anything on your data, and you can simply use the df and keep the data with, and you can keep the data for whatever reasons you want to work with it. Now, when you want to drop it, you can, let's say I want to see the help function first, df.drop_na. So within that, there are multiple things with which we can work on. Within drop NA, axis is by default 0. How, threshold, subset, in place, false. So there are multiple things that you can read about it in this help function, and you can read it yourself and learn more about this. So let's continue. Now if I do this df.drop_na on my data frame as it is, two rows were having NA values. Both of the rows have been dropped out. Now if I use this thresh equal to 1, in this thresh equal to 1, it means that at least one value has to be n- not null, and then that row will not be dropped. So in this case, because these 3 4 values were there, that those were not NaN values, so this has been kept. Now if I run this one, that you can drop it with a threshold value of 5, and in this case, again only um, 0 3 and 4 is coming, because in this only 4 values were not null, not 5, right? So if there were 5 values in this row which were not null, it would have been kept, but in this only 4 are there which are not null, so this is also dropped. Now if you want to do this, drop NA x is equal to 1. Now if you see the original data, uh, all the columns are having NaN value at least once. Now if you run this one, drop NX is equal to 1, all of the columns will be deleted because every column had at least one NaN value. Now you can also do a drop NA function with the subset of last name. So last name, within the last name, 4 values were not NaN, right? Only one row, the index 1 was having last name value as NaN. So based on this particular column name, the things can be done. Now this is how my data frame looks like. Okay, now I want to do some filling in, right? I want to fill some data at these NaN positions. You can also look into the help of df.fillNA, and within that there are multiple techniques. So you can learn about that, how you can uh, effectively use this, but I will keep this to you so you can explore it yourself. Now if I write this fill NA new, so at NaN locations, new has been written. So whichever value you want to fill in, you can simply do it with this. Now within the pre-movie score, this column, I want to fill the NaN values with 0, right? Now if I run this within that particular column, at NaN locations 0 is written. Now within this sex column, this new location was a initially NaN. So for that also we can write that I want to fill it with by default M. Now that you have used this fill NaM on this column, all the values which were having null value has been replaced by m. Now if you look into the data frame, it is looking like this right now, right? So it is again an n value because we have not saved any of the previous 5 6 commands in the data set. So that's why it is n again and again. Now if you want to do this, replace with average pre-movie score. So I want to fill the pre-movie score column with the average value. So first I will have to calculate the average value by using this dot mean function, and then I can replace the NN values for this particular column. So if I run this, you will see that in particularly in these two, 1 and 2 locations, the average value 7 has been written. Why? Because 6, 7 and 8 had an average of 7. Now df.fill NA. Now you can do it for complete data frame also. So within the columns where there were numbers, for the age column as well as the pre-movie score column, they were in the form of numbers, and mean value could have been found. That's why it has been replaced with the mean value. Previously we have discussed interpolation. There were two values, 25 and 75, and we had said that in the location 1 the value will be 25 plus 75 divided by 2. So that same thing will be done automatically now. Let's say first we sort the values, sort the data frame according to the age. So initially my age is having 63, NAN 51, 66, 31. So hypothetically I'm trying to first sort the values. So I'm selecting the age, right? Now after sorting it, my data frame looks like this: 31, 51. So these were the four values. And now I want to do some interpolation for complete data frame. Now you can see that in this pre-movie score NAN, post-movie score NAN again. I mean, because these two NAN values are in between 7 and 8 and 9 and 10 respectively, so these two values will be replaced with the 7 plus 8 divided by 2 and 9 plus 10 divided by 2. So if I run my interpolate function on it, notice that now because this NN value was there, so 7.5, 9.5, and even for these last rows, even for this last row, what has been done is, I mean, average has not been taken, but the previous latest value has been taken. So 6, 8 and 66 have been copied into this last row. So that's all. So we have learned a lot of things in this video, and we have learned about keeping the missing data, dropping the missing data, and fill the missed data. So all multiple things were covered. Initially we learned about the NaN values, NAT values. So everything was taught on a basic data frame, and then we also did some implementation on the data set. So within the data set we learned about how to handle different columns, how to handle the NaN values within the columns, how to get the values replaced according to our need. And in the end we have also covered about the interpolation. So most of the things are easy in this. In fact, everything in this video that has been taught is easy if you practice. So you can find the GitHub link of the code in the description of this video. Subscribe to the channel. Thank you, and let's meet in the next video.